Alright, you've made it to the bonus video. What is going on here? This is an optional video you could watch just to explain what's going on with a tangent function and why it was so different than sine and cosine. I have my calculator here with me, although the first part of this video I think we can do without a calculator. What is the tangent of 0 degrees? 0 degree finger, fold it down, flip your hand over the tan side. Ratio of the number of fingers above to below, square root of 0 divided by the square root of 4 over 2, so that would be 0. Let's do 30 degrees. 30 degree finger, flip over your hand, square root of 1 over square root of 3. Square root of 1 over square root of 3, when you rationalize it, is root 3 over 3. The value of root 3 over 3 is less than 1 because the denominator is larger than the numerator. So you're dividing by more than what you have. What's the tangent of 45 degrees? 45 degree finger, flip it over. Root 2 over 2 divided by root 2 over 2, that equals 1. Okay, here's where the tangent ratio equals 1. Now for sine and cosine, 1 was the maximum value for the output for the ratio. But for tangent, something different happens. For 60 degrees, fold down your 60 degree finger. Flip over your hand. Square root of 3 over square root of 1 is square root of 3. The square root of 3 is a number that's bigger than 1. So tangent doesn't have a restriction for the ratios that it gets out for any angle. What happens to the tangent of 90? 90 degrees. Flip your finger, fold your 90 degree finger, flip your hand. Square root of 4 over 2 divided by 0 over 2. That's undefined. So what happens when you go between 60 and 90? Looks like the tangent value is increasing, increasing, increasing. How far can it go? This is where we're going to use our calculators to figure out. What I designed is a little bit of an activity, really quick. Let's find out what our calculator says each of these answers are. The closer we get to 90 degrees, what happens to the ratio for tangent? So what we're going to start with is, let's do the tangent of 89 degrees. Tangent 89, I'm just going to double check, whoops, I'm just going to double check that we're in degree mode, cool. That says the ratio of the opposite side to the adjacent is about 57 to 1. So the ratio is like 57.2, let's do 90. This is not an angle in degrees, this is a ratio. That the length of the opposite side is 57 times larger than the adjacent side. So as you get closer to 90 degrees, this length, the vertical length, gets really long, the horizontal length gets really short. I can imagine that the vertical side is 57 times larger than the adjacent side. That doesn't mean it has a length of 57, that means it's the ratio of those side lengths. What happens when you use 89.9 as your angle? The closer you get to 90, what happens to your tangent value? That's 572.96 or 957. That ratio, the opposite side length, 572.957. The closer you get, this side length is a lot longer than that is by comparison. All right? Even though it still has 1 unit away, it's still 1 unit away from the origin. Let's do this one more time. 89.99 degrees. What's the tangent of 89.99 degrees? That's 5,729.578. 578. Now, it's not 10 times as big. It's something else is going on here. But it's getting really large, that the y-coordinate, the closer you get it to 90, the closer that it becomes to the x-axis. So the x is decreasing, the y is increasing, but not as much. It's getting, the y-coordinate is like 0.999 something, and the x-coordinate is like 0.0 something, very little. The ratio gets really large. Now I'm just going to do a button smash. I'm going to do a button smash. Let's just do a bunch of 9s, and let's see what happens. This is scientific notation. This is like thousands, millions, billions. This is billions of times larger on the y-coordinate than the x-coordinate. The closer you get to 90, the closer this becomes to an infinite ratio. And what happens when you, of course, obtain 90 degrees for your tangent? It's undefined. That's like having almost a ratio of 1 divided by 0. The opposite side is getting closer to 1, and the adjacent side is getting closer to 0. This ratio does not exist. So that's really what's going on, and why your tangent values for your tangent inverse can be anything beyond including 1. Okay, this is pretty much like an explanation. Just because I have some more time, if you have a point here, your cosine is your x, your sine is your y, and that's what it is in the unit circle. What does tangent mean? The tangent would be a length of this side from the point tangent to your circle to the x-axis. So as you rotate the point closer and closer, that tangent length gets longer and longer. That's really what tangent represents and why we call it a tangent. As you go around the unit circle, the tangents get longer and longer and longer and longer until it's like infinitely long. Alright? At 90 degrees, that tangent will be parallel to the x-axis, which is why it's also not defined. That was something just like cool to know. Thanks for watching.